Hi, welcome to the third module. This video will teach you how to handle missing values and blanks in a dataset. First, we will use the filter function to get an overview of the dataset. Then, functions of tidyr package will be introduced to you. They are useful tools for dealing with missing values in a dataset. Before we get into details, please be reminded that we will need dplyr and tidyr packages in this module. Please install them into your R. Now let's start by looking into the dataset. We'll be using this penguin dataset throughout the video. It contains information of around 300 penguins. Details of each penguin, including species, common death and length, body mass, and sex are provided in it. Suppose that we want to get all the factors information from item column. It is time-consuming to scroll down and identify all the factors. The levels function can do the work in an easy way. Specify the column inside the brackets of the levels function. Then we can get unique factor names. We learn from this result that penguins may live in these three items. If we only want to look at the penguins that live in Biscoe Island, we can use the filter function. This command can be used to find rows or cases that match with the condition you set. To better observe the result, let's create a new data frame called fieldType. Then specify the penguin's data in the filters function. And set the condition to item equals to Biscoe. Run this code and view the data frame. Then we can take a look at the filtered result. Moreover, we can also set numeric conditions in the filter function. Suppose we want to examine the penguins that are heavier than 3,800 grams. We can set the condition of body mass column larger than 3,800. By running this code, we will get this dataset that contains all the information from penguins heavier than 3,800 grams. Overall speaking, the filter function can help you obtain a quick overview of how the dataset looks like. In addition, it can also be used to deal with missing values in the dataset. To view all the rows that has NA in column delta 13, we can use the is.na function inside the filter function. The function is.na helps to specify the condition that a column has missing value. Run this code and we can get this data set that all the cases in delta 13 is shown as NA. However, when doing data analysis, we try to avoid analyzing dataset with missing values. Missing values may impact the accuracy of data analysis results and might mask relevant information. Thus, we can use the filter function and is.na function to get elements without missing values. Please be aware that is.na is written as an exclamation mark plus is.na. The exclamation mark carries the meaning of opposite or is not in our language. Let's run this command and see what we can get. Since the condition is set to be common length is not NA and delta 13 is not NA, the result will be a dataset eliminating all the missing values in these two columns. After eliminating NA, there are still blanks in the dataset. NA and blanks have different meanings in R, but we can also use the filter function to remove them. Let's set the column sex to be not blank by using the not equal to operator and use a pair of quotes with nothing inside to represent a blank. By running this command, the dataset will filter out all the blanks in the sex column. The filter function is a good tool to manage missing values, but there's other functions that may do the job in an easier way. First, let's use the DropIn function to eliminate all the rows that contain NAs. Before we do so, let's select all the cells in Penguin's data that are blanks and replace them with NA. With this step, we can make the data cleaning process simpler, as we only need to deal with NAs later on. Now we can run the DropIn function. By specifying the file name inside the brackets, all the rows with NAs will be dropped. As a result, all the cases in new dataset tidy1 are cases with certain values. In addition to dropping the NAs, we can also assign new values to them. With the fill function, we can set the NA to become the value of the above cases. To make it clear, let's look at this example of common length. The fourth row of common length is NA, and we would like to give it a value. Put the file name penguins and the column name common length inside the fill brackets and run the code. The NA will be replaced by 40.3, which is the value of the third row. The default setting of this replacement rule is filling downward. If you want to use the value of the fifth row to replace the NA in fourth row, you need to set dot direction to up inside the brackets. The last function we would like to introduce is a replace NA function. If the file is a data frame, this function can replace all the NAs in the specified column with the value assigned in the list function. Let's look at this example. The fourth row of common length and common depth are both NAs. If we want to replace NA with 40 and 18 respectively, we just put the conditions in the list function and separate them with a comma. Note that since common length is set to be 40, all the NAs in this column will be replaced by 40. To sum up, we've talked about filter, s.na, DropIn, fill, and replace NA functions in this module. These functions are very useful tools for data cleaning. In practice, the data you collect often contains a lot of missing values and blanks. The functions introduced in this module may handle this problem. As usual, here is a summary table for you to review the functions that we have discussed. Hope you enjoyed this video and see you in the next module.